next speaker is Leanne Young, How the Brain Makes Sense of the Moral Mind.
Perfect. So in my lab, we study the science of morality, how in the mind and brain we make moral judgments. And of course, morality, much like human pregnancy, is very messy and complicated and full of conflict. So people, and perhaps in different ways, people tend to disagree about what's right and wrong, both within a culture and also between cultures. And so what I want to do is zoom in on a key aspect of moral judgment that I think might be common across different moral codes. So for instance, how do we distinguish between murder and manslaughter? How do we identify attempted harms, including attempted murder, as wrong, even when no harm is actually done? So in other words, how do we reason about the mental states, what's going on inside of moral agents around us? So to do this, we constructed scenarios in the lab featuring both attempted harms and also accidental harms. So in the case of an attempted harm, someone might think some powder is poison, even though it's just sugar, and then go on and try to kill someone. In the case of an accident, someone might have good intentions. They might think the powder is sugar when it's actually poison, and then sadly accidentally poison a friend in spite of good or innocent intentions. And so what I want to know is what happens when we scan people's brains while they make these judgments of blame and forgiveness. And so most people, most of the time, say that the first kind of behavior is wrong, and the second behavior is forgivable. That's the basic rule. So what happens when we scan people's brains? It turns out that a group of brain regions is selectively recruited when people make these moral judgments of blame and forgiveness. And one of these regions in particular seems especially interested in what's going on in people's mental states. So the level of activity in this region is particularly high when subjects are reading about characters' intentions, whether those intentions are good or bad. But the response is relatively low when subjects read about other facts of the situation, like whether that powder turns out to be poison or sugar, for instance. Of course, people tend to blame and forgive to varying degrees, so what we'd like to know is whether the level of activity in this region actually predicts the kind of moral judgment that people make. And indeed, that is the case. So what I'm showing you up here is the direct relationship between neural activity in this region and the moral judgments that people make, in this case of accidents. So you can see here that our experimental subjects who have a high neural response in this particular region tend to focus more on agents' mental states, the innocent intention in the case of an accident, and therefore offer more forgiveness for an accident, whereas subjects with a relatively low neural response in this region tend to focus less on the mental state, more on the outcome, which is bad in the case of the accident, and therefore assign more blame to the accident. Now, it's one thing to show that there's this correlation between neural activity and moral judgment, but if this region plays a causally necessary role in people's moral judgments, then we might expect that disrupting function of this region should also disrupt this particular aspect of people's moral judgments. And so using a technology called TMS, transcranial magnetic stimulation, we're actually able to temporarily disrupt activity in this region of people's brains. And so just more generally, TMS allows us to transiently disrupt activity in specific parts of people's brains and then observe the consequences on behavior. This results in what we call a virtual lesion. And so we were able to use TMS to create these virtual lesions in people's RTPJs as they made moral judgments of these kinds of scenarios of accidents and attempts. And so this is what we found. When we disrupted activity in the RTPJ, people tended to judge failed attempts to harm as more okay, more permissible. They were more forgiving of those, focusing less on the fact that someone meant to cause harm and more on the fact that no actual harm was actually done. And judgments were also slightly more outcome-based in the case of an accident, too. And so what happens in populations of people who have trouble considering the mental states, particularly the intentions of others? So we looked at moral judgment in high-functioning individuals with autism and found a very similar sort of pattern. In particular, what you can see here is that the individuals that we tested were less forgiving of accidents, again, focusing more on the outcome of the action as opposed to the mental state, in this case, the innocent or good intention of the actor. So what's the big idea here? The idea is that even though it's impossible for us to see inside people's heads into what they're thinking and intending, we care a lot about what goes on inside, so much so that we have specific brain regions for helping us do this task.
So, a lot of people say that one of our most distinctive mental skills is so-called theory of other minds. Presumably it's not unique to humans, but it's especially developed in humans. Are there insights to be gained, therefore, by doing comparisons between humans and other species which have more or less ability to theorize, as it were, about what's going on in other minds?
There's a lot of interesting work going on in non-human primates with respect to theory of mind. So it seems like one interesting difference between human and non-human primates is that we're able to use theory of mind flexibly for all sorts of things like moral judgment and social interaction. Theory of mind seems to be particularly salient in non-human primates for competitive contexts. So that's one interesting difference, but of course there are many others too that are still being investigated.
Thank you. Over here.
In your research, have you looked at different ages of people in terms of the development of that region at different points in people's life?
Yeah, there's been quite a bit of research looking at the development of theory of mind over the lifespan, particularly from infancy through adolescence onwards. So theory of mind is particularly late developing, and so young children, if you give them a task like the one that I showed you, the moral judgment task, they tend to be very, very harsh on accidents, and so their judgments are particularly outcome-based even after they're able to engage in theory of mind for other purposes. And so it seems like mature moral judgment takes a long time to emerge.
Okay, please.
How specific is this brain region to moral judgment? Is this same region also active for such things as riding a bicycle?
Maybe not riding a bicycle, but this region isn't actually particular to moral judgment. It's particular to thinking about other minds, thinking about other people's mental states, like their beliefs and intentions. And so this is important for any sort of situation in which you'd want to know what someone is going to do. If you're predicting behavior, if you're explaining behavior, if you're making a legal judgment, and so on. And so it's not specific to morality, it's specific to social cognition, which is very important for moral reasoning.
Please.
Since much of ethics is based in religion, did you have a graph of any sort that tabulated the differences between people of intense religious background versus those in the same religion but with less intensity?
Have you investigated any influence of degree of religiosity on these effects?
That's interesting. So the one study that I know of that looked not at just levels of religiosity independent of the religion, but rather at, I think the study looked at Jewish and Christian subjects on moral judgments, not of the kind that I showed you, but I think what they looked at was children's duty to their parents. And it turned out that Christians tended to care a lot more about kind of children's intent toward their parents, whereas Jews really focused on the fact that they did what they were supposed to do. I wasn't an author on that study, but that's what they found.
Okay, potentially deep water there, I think. Yeah, let's keep going.
Is forgiveness learned? Is forgiveness learned? Is it a learned behavior?
Oh, learned, yeah. It's a good question. So like I said in response to another question, it seems to develop slowly over time. Certainly parts of it could be learned from your culture, and what I didn't address in this talk is the cultural contributions to these kinds of moral judgments and what you learn from the people around you. It seems like forgiveness does depend on an innate capacity for theory of mind, and so there might be different components, some learned and some innate.
Thank you. Over here.
Is there any evidence that people who have a lower capacity in that region of the brain, like someone with autism, could develop that area, strengthen it?
So that's something that we're looking into now, the neural basis for these sorts of social cognitive differences in autism. What we're trying to do is develop tasks to actually uncover some of these differences, like the moral judgment task, because high-functioning individuals with autism tend to do quite well on standard theory of mind tasks, precisely because they have developed these compensatory mechanisms that you refer to. And so there's definitely hope. The question is whether those compensatory mechanisms depend on the same neural processes that support theory of mind in your typical subject.
But one thing that I detect in some of these questions is that presumably it's a completely different question whether a capacity can be developed more or less by learning, and whether it's also located somewhere in the brain. These are just two different dimensions, aren't they?
I think they might be related, but they're certainly different dimensions.
Okay, thank you.